Well, let's take a look. First thing here, it says similar polygons. They're basically two polygons with the same shape, but not the same size. So it's basically, as it says here, it's similar polygons. They've either been enlarged, made bigger, but kept the same shape, or made smaller. It's like a scale drawing. So here's the thing that you need to realize in this. It's most important, and that is similar polygons have the same number of sides. Okay, their corresponding angles are congruent. That's the second thing, and the corresponding sides are proportional. So if you look, there are three things there that you need to know about similar polygons. Number one, they have the same number of sides. Number two, corresponding angles are congruent. And number three, corresponding sides are proportional. So you have examples here of similar triangles, similar pentagons, and similar quadrilaterals. Okay. Then they give you some pictures of polygons that are not similar. Now, in this first one here, you see they are all triangles, so they all have the same number of sides. That meets the first criteria there. But then the second one is that all of their angles are congruent. Their corresponding angles are congruent. So if you look at this triangle right here, I have an obtuse triangle, but I don't have any other triangle with an obtuse angle. Okay, so it's kind of along those lines. And obviously it doesn't fit that, so my sides aren't going to be in proportion. Here, I have no way to tell if my sides are in proportion either, or if my angles are in proportion, or my angles are the same. Here, we know that, even though nothing is labeled, since they tell us it's similar, we know that this side here and this side here are in proportion. So if this is A and this is B, A to B would be in the same proportion as C to D. Okay, so I'm going to say A over B is equal to C over D, because they tell us that it's in proportion. Here they don't tell us, so we have no way of knowing. And you can even tell, this angle is different from this angle, is different from this angle here. Okay, so let's take a look at example one. It says, suppose triangle ABC is similar to triangle JKL. Okay, now this is just very like if you had, I don't know, a congruent statement, to where angle A and angle J would be corresponding angles. So if it's similar, we would know that the measure of angle A is equal to the measure of angle J. We would also know that the measure of angle B would be equal to the measure of angle K. And we would know that the measure of angle C is equal to the measure of angle L. Okay, now I could actually draw this triangle out. I don't know, if these are the right numbers or the right shape, but it doesn't make a difference. I could just do it for the sake of showing you guys how to do this. So then I could do my I want to make this one a little bit smaller because it's similar but not congruent. So this would be J, K, L. So in this, what this is telling us is that angle A and angle J, they're equal. Angle B and angle K are equal. Angle C and angle L are equal. And then if you notice, I can take this, even out of my similarity statement, I can look at my sides, AB and JK. AB and JK are in proportion, and that's the same proportion that you have for BC and KL. BC and KL. So I could say, I'm going to erase this over here just so I have more room without going off here. But I could say AB over JK is equal to BC over KL. And then I have my last side on here. I have AC and JL. And if I look at that, we'll flip to a different thing here. I have AC and JL, so that's equal to AC over JL. Now, one thing about it, when you take a look at this, this is very important. I have this triangle listed on top, and it has to be all the same. I have this triangle listed on the bottom. Okay, I couldn't flip this around. I could not say AB over JK is equal to KL over BC. That would not be equal because the 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 triangle that I start with and the naming of stuff is a triangle I have to keep first. This has the AB triangle first, and so it has to remain on the top. Now I could flip it over and say JK over AB, but then it would be KL over BC is equal to JL over AC. You have to keep the proportions the same in that regard. So like here, I have the JKL on the top all the time and the ABC on the bottom all the time, and that's fine, but I have to keep the order the same in that regard. Okay, boy, that got messy real quick. So then, when we take a look at this, it says, based on the similarity statement, which angles are congruent and which sides are in proportion. And that's what I just went all the way through and just erased. So I know that the measure of angle A and J are congruent, B and K are congruent, C and L are congruent, and then I could have AB over JK, because those are my first two letters. And then I could say side BC over side KL. I need to put that these are segments. And then I can say side AC over side JL. And those are my sides and congruents. So that takes care of number one.